Alright, pencils are down. How many of you guys got the first 2 pages done? How many of you guys got at least the first side done? Okay. Alright, so this is a little bit more of like everything that we've covered in Unit 6. Yesterday was a little bit more of the more recent stuff that we've covered in Unit 6. Alright, so looking at the first one, there's an example for you for extended form. So what is 3 to the 6th power look like? What does 3 to the 6th power look like? Kylie? Alright, what about 6 to the 2nd power, or 6 squared? No? Okay. Number 2 says show how 2 to the 4th power is the same as 4 squared. So what do you do here with this one? Right. So you would do 2 times 2 times 2 times 2. So 2 times 2 is what? 4. 4 times 2 is what? 8, and 8 times 2 is what? So 2 to the 4th power equals 16, and 4 times 4 equals 16. Alright, so that's essentially how you would show that they are the same. So 4 to the 6th power equals what? Aiden? 48? 4 times 4 times 4 times 4 times 4 times 4? Everybody? Jonathan?
1096.
Yes. So this equals 4,096. Alright, 16 times 16 times 16 equals what? Christiana? 4,096. So again, if you didn't get this right, please make sure you are copying down the right information. Okay? Because this is, you have 2 study guides now, essentially, you're going to be able to look over tonight, and I want to make sure that you guys have the correct information on it. Alright, show how 2 to the 9th power is the same as 8 to the 3rd. So you have 2 to the 9th power, which equals what? Delilah? Yes. And then 8 times 8 times 8 equals Delilah? Alright, the 3rd row says what is the value of xy if x equals 5 and y equals 10? So what operation is going on between x, y? What operation is going on between x and y if there's nothing in between them? Kaya? Multiplication. So then I'm just going to plug in x for y, or x and y. I'm going to do 5 times 10 equals, it's 5 times 10, is that right? 50. Okay, so again, what is the value of xy if x equals 12 and y equals half? So then I'm going to do 12 times 0.5 or half. What do I get? Christiana? 6. And then the last one says what is the value of xy if x equals 9 and y equals 2? So what do we plug in now? So 9 times 2 equals 18. Alright, how do we feel so far about the first, technically, 9 problems? I know that these were a little intense just because you had to multiply, 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 but remember, when you're doing exponents, are you multiplying 4 times 6, or are you multiplying 4 times itself 6 times? Okay. So it says write an expression for this situation. 3 feet less than John's boat. So what is this going to look like? 3 feet less than. Remember, less than does something to our variable and our number. What does less than do? You guys remember what that phrase is called? Remember what the phrase is called, Zoe? It's a switch phrase. So with that being said, Zoe, does my 3 go first or does my 3 go second? You said second? Yes. So whatever letter you pick, it would be x minus 3. Okay? Alright, so the next one says write an expression for the situation, 2 dogs less than the shelter. So again, we have that switch phrase right there. So what do you think our expression is going to look like? Delilah? X minus 2. And the last one says write an expression for the situation 2 minutes less than Hayden. And again, you have the switch phrase. So what is that telling us we have to do? Wyatt, what's it telling us we have to do if we have that switch phrase in it? We do have to subtract, but what does it mean when we have a switch phrase? Are we putting the variable first or are we putting the number first? Yes, you put the variable first if it comes second in your problem. So then this would be x minus 2. So how many of you guys kind of forgot about those? It's been a while since we talked about expressions, isn't it? Alright, do not forget though that if that's something that you struggled with, put a little star next to number 4 so that you know that's something that you do need to go back and look at tonight before your test tomorrow. Alright, we're skipping these rows because we don't talk about associated property, we don't talk about commutative property. We do, however, talk about what? Distributive property. So it says rewrite using the distributive property. It's not asking you to solve anything. It's just asking you to do what with the number on the outside. What's it asking you to do? I'll give you a hint. It's part of the name of the property. Cameron? So when you distribute your number in, you end up with 6 times A plus 6 times 4. That is all this question is asking you to do. It is not asking you to solve it. It is not asking you to combine it. It's just simply asking you to distribute it. Okay, you guys remember this part? Remember how to do this? Okay, if you don't, again, put a star next to number 7. So whatever you have struggled with or you weren't sure about so far, put a star next to it so you know either to look at the information that we're covering today or to go back and look at it in your notes. Alright, so for the second one, someone will raise your hand and tell me when I distribute my 2 in, what is it going to look like when I rewrite it? Hello? You said 2 times 2a.
Minus 2 times 6.
Why did you subtract? I can hear what you're saying.
When the 2 is like not distributed, minus 2a minus 6.
Nope. It's not why we subtracted. Why did we add in the first one then? Why did we add in the first one? Why did we subtract in the second one? Why will this not focus? So you did a fantastic job with your distribution and knowing that there's subtraction in there. But we have to understand why we're subtracting or why we're adding. Canada.
Original problem, it said 2a minus 6.
Because in the original problem, it says 2a minus 6. So remember, you bring whatever operation is in your original problem down between your 2 numbers that you distribute. All right? And then the last one, someone tell me what it's going to look like when I distribute half in. All right, Aiden. You said equals or plus?
Plus.
Alright, so how did we do with those 3? Are you okay with them? Again, please make sure you're getting this information down if you didn't get it before or you skipped it because you weren't sure. Alright, give me a thumbs up and we can slide over to the next page. good? Alright, let's slide over. So now this part of the distributed property, what is it asking you to do? What's it asking you to do with this part of the distributed property? What?
To rewrite them.
You what?
To rewrite them.
You have to rewrite them, but how are they different from the ones we just did?
They don't have parentheses.
Right, they don't have those parentheses, so if you remember way back in the day, when we did distributed property, we used GCF, right? To find the number that's gonna go on the outside. So essentially, if you need to use GCF to solve some of these problems, that's what you need to do. So for this first one, I'm just gonna fit it right here. So I have 28 and I have 42. So someone list the factors for 28 for me. So we have 1 times 28. 2, raise your hand. What do we multiply 2 by to get 28? William?
14.
Alright, 3. Does 3 work?
No.
Nope, 3 doesn't work. Alright, so what about 4? 4 times what, Troy? 7. 5. Does that work? 6. Does that work? 7. So we're starting to repeat. Alright, over here we have 1 times 42. 2 times what? I have 21. 3 times what? 14. 4, does 4 work? 4 times what? Does it work? Does 4 work? 4 doesn't work. What about 5? Does 5 work? Alright, what about 6? 6 times what? 7. So my GCF, sorry, my GCF goes on the outside. Oh my lord. Hold on. We're not gonna talk about it.
No.
Alright, so my GCF goes on the outside, and then the number next to it goes on the inside. So 7 goes on the outside.
But there's one greater than it's 14.
Oh, you're right. That's why I keep y'all around. Alright. Thank you. So we have 14 as our GCF and 3 and 2. So, 14, if I could get this to work, that's why you don't use pen, y'all. 14, and then, so 14 times 2a minus 14 times 3. So that's what that one should look like. I know I got that all messed up, I apologize, y'all. Alright, so the next one, 12a plus 24, yes. 12a plus 24 should be a little bit easier, right? Because 12 and 24 are smaller numbers per se, plus to me, it's a lot easier to see which one is gonna go into which one. So, what number goes into both 12 and 24? Christiana? 12. So 12 is gonna go on the outside. Christiana, what's the first thing that's gonna go on the inside of my parentheses? Huh? So 12a. If I'm pulling 12 out, so technically 12 times what gives me 12? 1. So you can either put 1a or you can just put a. And then I'm gonna say 12 times what gives me 24? 12 times what gives me 24? Kyra? 2. Okay? And the last one, again, I don't necessarily feel like we need to do the GCF thing. If you need to, by all means, go ahead. But what number, which is the biggest number, goes into 15 and 45? No, 15. So 15 goes on the outside. No, what do I multiply 15 by to get 15? So this one, I'm not gonna write the one, I'm just gonna write A because we should know if it's a variable with no number, what's the value of that number? 1. And then 15 times what? No, it gives me 45. Great. Alright, so this might be one that you need to kind of go back and revisit a little bit. Just remember. Alright? Number 9, someone help me out. What do I do? Number 9. How many of you guys got to number 9? Okay, so you should definitely have your hands up. Alright, Levi, what number did you put on the outside? You what? It's okay, so then what number goes into both 10 and 12? 2. So 2 goes on the outside. So Levi, 2 times what gives you 10? So 5A goes there, plus 2 times what gives you 12? 6. Alright, so even though you might not have got to this one or these questions, it's still not the hardest thing. Okay, so just kind of think to yourself, what works, what goes in, what's the biggest number? Alright, so 2A plus 22. What is the biggest number that will go into both 2 and 2A? Gemma. 2. So 2 goes on the outside. So Gemma, 2 times what gives me 2? 1. Okay. And 2 times what gives me 22? 11. Alright. And the last one. Someone walk me through this without me guiding for this last one. Alright, Zoe R. So what number is the greatest between these two?
6.
No. Can you multiply 18 times 2 and get 36? Huh? Huh?
It's not right.
No. Because if you do your factors, what is 18 times 2? Okay, so then what is our GCF? What's our greatest common factor? 18. So 18 will go here, all right, and then walk me through the rest of it. Perfect. All right, so raise your hand if you got to row the 10th row. All right, if you did not take a minute to at least get 10A and 10B done. The biggest one we got. Longest question. All right, stand up when you have your answer for 10A and 10B. All right, have a seat. So it says evaluate 30 plus 4 to the unknown power when x equals 2. So this is something that we haven't necessarily done per se, but does it still follow the same guidelines of knowing, having an unknown number and then knowing the value of it and plugging it in? Okay. The difference is though, our unknown value is what? It's our what part of our problem? Kaya? The exponent. So when I rewrite this, I'm going to do 30 plus 4 squared because x equals 2 in this problem, right? Does that make sense? And then from there, what type of problem does this become? Noah? Right. A PEMDAS problem, you just go straight through order of operation. So don't forget, if you struggle with this, I could write my letters and numbers correctly today, that'd be fantastic. If you struggle with this, remember the strategy where you put this down the side of your problems. And that way it helps you stay and continue in the order it's supposed to be. Do we have parentheses? Do we have exponents? Yes, we do. So we're gonna do 4 times 4, which equals what? 16. So then this becomes 30 plus 16. And then we don't have multiplication or division. We do have addition. What is 30 plus 16? 30 plus 16. Java.
46.
46. All right. The next one says evaluate 13 plus 2 to the x power when x equals 0. All right, so when I rewrite this, I'm going to do 13 plus 2 to the 0 power, which gives you what? What do you guys think? 13, because 0 to the 0 power, you're going to be multiplying by 0. You will not see 0 or 1, so to the 0 power to the first power. You won't see that on your test or the EOG. Okay, so this just becomes 13. All right, the last one. Excuse me. 21 minus 2 to the unknown power. So we have 21 minus 2 to the 4th power. What does that mean? What are we going to do? How do we solve this problem? Someone other than Noah, someone other than Christian. All right, Lily?
You do PEMDAS, so first you do exponent, and so you solve the exponent, which would be 2 times 2 times 2 times 2, which is 16, and then you do 21 minus 16,
Which gives you?
5.
All right. Now we're getting into solving equations. Some of these are very easy. The bottom 3 are not hard, but what makes them hard? What makes them hard? What? That they're fractions. All right, so raise your hand if you have done 11, 12, and 13. Okay, if you have not done 11, 12, and 13, I'm going to give you time to do those. If you've already done them, but you didn't finish the back, I want you to go to the back and work on those. I'm going to set the timer for 5 minutes, and then we're going to go and continue on. Are you done with everything? Just the whole thing. 11, 12, and 13. Alright, so when it says find the solution and we have a variable in there, what do we have to do? What do we have to do? What type of operations? Jonathan, what type of operations do we have to do? Like when we're solving for x. Yes, we have to do the inverse. So if it is x minus 22 or 28 equals 30, what are we doing in this problem? What's the opposite of subtraction? Christiana? Addition. So I'm going to add 28 here. I'm going to add 28 here. Alright, so x is going to equal, what is 28 plus 30? Troy? 58, and then to check to make sure, I plug 58 in, and I do 58 times 28 equals 30, and I know that I am correct. How many of you guys remember that? Okay, alright, so the next one it says, find the solution, x minus 13 equals 26. Please stop. Whoever is clicking stop. So what is the opposite of subtract? Camden. Alright, so I'm going to add 13 right here, add 13 right there. So x is going to equal, what is 26 plus 13? Delilah? 39. And then to check to make sure I'm right, I plug that back in and I do 39 minus 13 does give me 26. I know that I am correct. Okay, questions about the first two? Alright, the next one it says x minus 8 equals 10. So what is the opposite of minus? Noah? So I'm going to add here and add there. So x equals 10 plus 8 is, no, 18. Then I plug 18 minus 8, and that does give me 10, so I know that it checks out. So those three are pretty easy, right? Like not real hard. So now we're gonna go on to the next one, the next couple, next three. Alright, these get a little bit more difficult if you're not careful. Alright, so what operation is going on between 4 and D if there's no operation in between the number and the variable? I need new friends. Leo, what operation is going on between 4 and the D if there's no operation in between them? Yes. So then what is the opposite of multiplication? Division. Alright, so from here, I know I have to divide by 4, and I have to divide by 4. Now, if you did this, when you did your division, so because we're saying 4d equals 2, we divided by 4 here, right? We're dividing 2 divided by 4. So if you did this and you changed it to 4 divided by 2, you're going to get the wrong answer. How many of you guys did this? Good. You did it? Okay, and that's fine. Because naturally we like to make it as easy as possible on ourselves, right? This is not the case. You end up doing 2 divided by 4. So you're dividing a smaller number by a bigger number. Which will give you, what will D equal when you do 2 divided by 4? Christiana?
0.5.
Huh?
0.5.
Yes, 0.5. And this is where you have to definitely go in and check to make sure your answer is right. Because if you do it this way, you get 2, right? And 4 times 2 does not equal 2, does it? So that's when you would say, okay, I know that I'm wrong because when I go and I check it, I don't get the same answers I'm supposed to. So then I plug it back in and I do 4 times half gives me 2, and I know that I am correct. Okay, so how many of you guys flipped it and then you got the wrong answer and then you're like, I don't know what to do? And that's okay. That's why we're going over this. But that's also why the check is very important, because if you don't go back and check, you don't realize you did anything wrong, right? So you got to make sure you're going back in and you're checking. All right, the next one, 20q equals 4. All right, so what operation is going on between the 20 and the q? Kylie, what's the opposite?
Addition.
So I'm gonna divide by 20 here, divide by 20 there. So 4 divided by 20, so Q equals what? Q is gonna equal what? 5. Can we simplify that more? Can 2 go into 2 and 10? Which will give me 1/5. But yes, 2/10 is also right as well. You just have to simplify it. Alright, so now when I go back and I check, I'm gonna do 20 over 1 times 1 over 5, which gives me 20/5. When I simplify that, or sorry, when I change it back to a mixed a mixed number, what do I get when I do 20 divided by 5? What do I get when I do 20 divided by 5? 4. So I know that my answer is correct. Alright, last one for this. So we have 39b equals 13. What do we do here? What operation are we doing? Aiden. Okay, so I divide by 39, divide by 39. Alright, what does b equal, Aiden? Nope. Not 2/10. How about 1/3? Would 1/3 work? Alright, so B, yeah, B is gonna equal 1/3. And when you plug this back in, you do 39 over 1 times 1 over 3, which gives you 39/3, which when you change it to a mixed number, 39 divided by 3 gives you what? If you're not sure, do the math and figure it out. Don't sit there, do the math and figure it out. Stand up when you have your answer. Alright, Isaac, what'd you get when you did 39 divided by 13? So then we know that our work is correct. Alright, moving on. So the last 3 on the bottom, raise your hand if you got those finished. Okay, I'm gonna give you like 3 minutes to get those done. And then we will go over those. Stand up when you have them finished, and you've shown all your work, and you check to make sure your answer is correct. Alright? So someone walk me through how to solve 13. So I have 18 equals 2/5 x. Alright, Lily?
So first you have to do 18 divided by 2. 18 over 1 divided
No.
by 2 over 5.
Nope.
And the easy way.
No. The process, and I had to get into second period a little bit about this. What do we always do first when we're solving for equations? Let me rephrase that. What do I always model for you guys first? What do I always model first? No. The opposite operation. And the reason I always model that, especially when you get to the last 3 problems on this paper, next year you go into 2-step equations. If you are not doing this, and this, and this, and this, you are going to forget it. And next year you're going to be like, I don't know what to do. I don't know how to solve 2-step equations. You've got to get into the habit of isolating that variable. Because when it comes to 2-step equations, you have to isolate it, which means you have to do your subtraction and then your division. Where you have to do 2 operations within that first thing to get your answer. So if you are not writing it and crossing it out, you need to. That is something that you guys have got to do. All right, so Lily, what is the very first thing that we have to do in this problem?
First, you have to divide 2/5 by itself and then divide 18 by 2.
So why are we dividing 2/5 by 2/5?
So we can isolate the variable.
And why are we dividing?
Because it's multiplication. So
All right.
we'll do the inverse.
So now I'm doing 18 divided by 2/5, right? All right, go from there.
So the easy way to do that is to flip 2/5 and do the inverse of division. So you have to do 5 halves times 18 over 18, which will get you 90 over 2.
Okay.
90 over, and then you have to simplify. So 90 over 2 simplified is 45.
All right, so we're saying that 45 is what x equals. So now we have to plug this back in and check to make sure our work is correct. So when I do this, I do 2/5 times 45 over 1, which is 2 times 45, which is 90 over 5. And then when you simplify that, what do you get? What's 90 over 5? You don't have to do any math because you've already done it, right? If you did this, you essentially are doing 18 times 5 gives you 90, 1 times 2 gives you 2, right? So essentially you're redoing the problem. So why do I have children looking at me like I got 47 heads right now? The answer is on your paper. Yes, baby. Yeah. Does she have the information? Do you have your last link information? She said no. I'll send her to you. Alright. Let's take your iPad, Miss Birdie. So, what is our answer? 90 divided by 5. What's the answer? Camden? 18. So that one checks out. Alright, the other ones are a little bit easier, per se. So we have 1/5 W equals 5. So what operation is going on in our problem? I'm not asking you to solve, I'm just asking you to tell me what operation is going on in this problem. Elisa. So what operation is going on between 1/5 W? And what is the opposite? Alright, so I know that I have to divide 1/5 by 1/5, and I have to do 5 divided by 1/5. So 5 over 1 divided by 1 over 5 equals 5 over 1 times 5 over 1, which gives me 25 over 1, which essentially is what? What is 25 over 1? This one should be easy. I should have a lot more hands. Levi. 25. So W equals 25. So now I gotta plug it back in and check my work. So I'm gonna do 1/5 times 25, which gives me 25 over 5, which gives me what? Which 25 divided by 5? Delilah? 5. So I know that my work is correct. Alright, and the last one. 3/4 equals 1/4 W. What operation is going on in our problem? Haley. What's the opposite? So I'm going to divide by 1/4, divide by 1/4. So I do 3/4 divided by 1/4. Kaylee, what do I have to do when I'm dividing fractions? So I have to do keep, change, flip. So I keep, I change, and I flip. So I get 12/4. Kaylee, what is my answer when I simplify or change it back to a mixed number? What's 12 divided by 4? Yes. Alright, and then I plug this information back in, so I have 1/4 times 3 over 1, which gives me 3/4. So minus the first one down here, just because the numbers aren't as nice. How about these two? Were these two that hard? No. But what happens when we see fractions or decimals? What happens? Delilah? Well, that's what we do. But what happens when we see fractions and decimals in situations like this? No. You make it way harder than it actually is. What else? Because I see it happen all the time. Okay. So same thing, you overthink, you make it harder. But the biggest thing that I see is this. Your head literally explodes because you're like going, and you're like, yeah, I'm so confident. Oh my God, there's a fraction, what do I do? Like that's legit exactly what happens. Like you guys are rocking and rolling and then we throw in something that is a teeny bit different, and then it's like, I have no idea what I'm doing. Alright, flip your paper over. The top part is just more essentially order of operations, so we are going to skip that. And we're going to jump down to 16, 17, and 18, because they actually go hand in hand with each other. So you do 16, you do 17, you do 18. And you're using all the same information. So it says, at the state fair, the caramel apples cost $1.50 each. Create a table where X is the number of apples and Y is the total cost. So I went ahead and kind of wrote the example down. You just kind of had to finish the chart for this one. So your equation is Y equals 150X. So for one apple, it costs how much? Costs how much for one apple? Christiana? Okay, so then for 2 apples, what's it going to cost? Aiden? $3. For 3 apples, what is it going to cost? Troy? Did you say $4.50? Okay, I just didn't hear you, sweetie. Alright, so table is complete. Now it says write an equation to represent how the total cost depends on buying X number of apples. So again, that was already kind of done for you here. So you just have to transfer this, so Y equals $1.50X. Now, the table is small, so I'm gonna skip some lines just so it's a little bit easier for us to see. But if you did not skip lines, that is perfectly fine. Or if you're not there, even better. Alright, So, this is my x, this is my y. What is the name of my x? What's the name of my x? What's the name of the x? Levi. It's the independent, so is it the apples or is it the cost?
Oh, X is,
Yes, so number of apples, or if you just wanted to put apples, that's fine. And then my y is gonna be what?
total cost.
So the cost, I'm just gonna put a money sign. Now, I'm gonna put a 1, I'm gonna skip a line, put a 2, skip a line, put a 3. And the reason I'm skipping lines is just so it's not as cramped together. Does that make sense? And I'm gonna do the same thing with my money. So again, using the information from the table that we just created, I'm gonna start at the first line, skip a line, $3 on that line, skip a line, and $4.50 on that line. And then I'm simply going to not put the dot in the right place. Thanks. Come on. Close enough. Okay, that one. So my line is going like that. Now technically it would be closer together, but again, because the graph is so small, I did spread out a little bit. That does not mean you have to. If you didn't spread it out and you still understand what you're doing, perfect. Please make sure though that your graph is right. Now how do we check, like let's say that I put 4 right here. What would I do with my equation? So this is my original equation, right? So if I just put 4 on my graph and I wanted to find out how much money it would cost me for 4 apples, what do I do with my equation? What am I going to do with that 4 on my x-axis? What am I going to do, Delilah? Yeah, I'm just going to substitute it in, right? Because it's a value for x. So then I would take this out, and I would do times 4, and then I would get my answer. So 150 times 4 is going to be what? Right, so y is going to equal $6. So then, if I wanted to continue this, I would put $6 right there, and I know that this would be the next dot on my line. So that is how you use a graph with your equation. You pick a number that is along the bottom line, plug it in for x, and then just solve it. All right, let's go over to the next one. Excuse me. So it says your cell phone company charges $30 a month. Create a table that shows how much you pay the cell phone company, which is your Y. Show how much you pay the cell phone company depends on the total number of months of service. So if I put 1 month, because x equals month, it just told me that. So this is my month, this is my money. So for 1 month, how much does it cost me? Camden? $30. All right, so for 2 months, how much does it cost me? Jasmine? $60. For 3 months, how much does it cost me? Gemma? $90. All right, so then what is my equation? So I know y equals something, but what's the rest of my equation? So y equals what? What was our process that we did here to get this information? Delilah? So 30x, we agree with that? All right, down here on my graph, this is my x, this is my y. So what does my x represent? What's my x representing? Jonathan?
X represents the amount of months.
Okay, so number of months. And then what does my y represent?
Y represents
So again, I'm just gonna use that money sign. Alright, so based off of the numbers on my chart, I'm gonna put a 1, skip a line, put a 2, skip a line, put a 3. Same thing on the going up, I'm gonna, start on that first line, I'm gonna put 30. Skip a line, put 60, skip a line, put 90. And that is what my line should look like. Alright, questions about those? Alright, for your homework tonight, I am gonna let you get started in class. If you did not finish this, you have to finish it. Okay? So you're essentially doing 14, B and C, 15, A, B, and C, 16, 17, 18, B, sorry, C. Zoom out. So you're doing these 4, this technically 1, and these 6. Get started now. This is your review for your test tomorrow. If you are done, put it in your notebook, don't glue it in, and you can work on Imagine Math or Lexia.